So here we are going to look and discuss the stop and wait protocol, which is used usually for noiseless channels. So what's stop and wait? When anybody mentions stop and wait protocol, or wherever you see it, or anybody mentions it in front of you, you have to remember the following things. The stop and wait protocol is a data link layer protocol for the transmission of frames over noiseless channels. It provides unidirectional data transmission with flow control facilities, but without error control facilities. This is very important, and you have to put two lines under this. So it provides flow control, but no error control. So it means it can facilitate the link adaptation process, how much data you should send based on the capabilities of the receivers and the situation of the link that connects the transmitter with the receiver. But if something goes wrong, this protocol cannot help in error control. It doesn't have the capability of storing the packet that was not received successfully and then recombine it with the retransmitted packet again, and then try to make. Why we recombine the missed packet or dropped packet? We combine them using some mathematical techniques, one of them called maximum ratio combination, in order to improve the signal quality, signal to noise ratio quality. If you improve the signal to noise ratio quality, you will increase the probability of decoding your packet successfully. But this protocol, unfortunately, stop and wait, doesn't have this functionality. That's why it doesn't buffer your data, it doesn't store it, it doesn't combine it. It's like dumb protocol. It's not intelligent or smart. And the idea of this protocol is very simple, straightforward. After transmitting one frame, the sender waits for an acknowledgement before transmitting the next frame. Indefinitely here. There is no specific time that the transmitter needs to wait for an acknowledgement. It's not a defined time. That's why this results in a severe degradation in the throughput, because the more time you wait, the less data you transmit, and therefore your throughput, overall throughput, which determines your internet speed, decreases significantly, which is not a good thing to have. So let's talk about the primitives of stop and wait protocol from the sender side and the receiver side. So what does the sender do? What does the receiver do? Sender has two rules. The sender is functioning according to the following two rules. One, send one data packet at a time, only one data packet at a time, not bunch of packets at a time. Rule 2, send the next packet only after receiving an acknowledgement for the previous one. You cannot move forward sending another packet until you receive an ACK for the previous one. And that's why we have the throughput performance of this protocol is very low, not that good. Receiver side, the receiver job is to receive and consume data packets. After consuming a packet, the receiver has to send an ACK to the transmitter. And this process, we call it the flow control. Once the receiver sends an ACK, the transmitter understands that the packet was received successfully and decoded to the upper layers, and now he can transmit the next packet. So how it works, the procedure, you have the sender to your left-hand side and the receiver to the right-hand side. It sends data packet and then it waits for an acknowledgement. Once it receives the acknowledgement, it sends a new data packet, and so on and so forth. What are the problems with this protocol? The problems associated with stop and wait protocol. Problem number one. The first problem happens due to lost data. And the problem is caused because of the following two reasons. One, the sender waits for an ACK for an infinite amount of time. The receiver waits for an infinite amount of time. So these are the two reasons for the lost data. The second problem is a problem due to lost ACK. The sender waits for an infinite amount of time for ACK. So if the ARQ is lost, the transmission is stopped. The third problem is problems due to delayed ARQ or data. Let's say that after a timeout on the sender side, a delayed ARQ might be wrongly considered as an ARQ of some other data packets. So you transmit a packet, you wait for its ARQ, but it's not coming. The timeout is over now. The time in which you are allowed to receive an ARQ from the receiver is over. And then after the time is over and you proceed with transmitting a packet, you just receive the ARQ of the previous packet. So the transmitter gets confused here. So these are the main three problems. So if we have these problems with stop and wait protocol, what's the solution? The solution is to improve it. Think of ways or methods and techniques that can solve some of these problems. This is how you develop your projects. This is how you improve your ideas. This is how you improve other people's work. You see what the scientists, what the people, researchers, engineers have done, and you analyze it, investigate it, and then you find the problems in it, things that you are not happy about, and you would love to change, and then you just try to improve one of these features to end up having a new protocol or a new method or a new project that's better than the existing ones. So stop and wait ARQ protocol. The idea here of stop and wait protocol is like straightforward. After transmitting one frame, the sender waits for an acknowledgement before transmitting the next frame. But the key difference here is this. If the acknowledgement doesn't arrive after a certain period of time, the sender times out and retransmit the original frame. So what does this mean? This means that there is a certain period specified for the reception of each acknowledgement for for any packet you want to transmit. If the acknowledgement doesn't arrive within this certain period specified by the transmitter, then the timer will get expired and it retransmit the original frame one more time. So what's the stop and wait protocol? If you want to define it in a simple way, you can say it's basically a stop and wait protocol, the protocol we learned before, but with timeout timer and sequence number. Timeout timer, so that if the ARQ is not received within a certain period of time, I stop receiving an ARQ, it gets expired, and I automatically understand that there is a problem in the packet I sent to the receiver, and I have to send it again. I don't need to wait for that ARQ, because the ARQ might be lost in the road, or the packet might not have been received by the receiver. And therefore, the transmitter here kind of getting smarter a little bit and predicting that something wrong happened and I need to do something. I don't need to wait indefinite amount of time. And sequence number is useful to avoid misordering the packets or any problems related to ordering the packets in their correct order. So stop and wait protocol in this diagram shows how stop and wait ARQ protocol works. You have the sender to the left hand side and receiver. The sender sends the data packet to the receiver. If the receiver was able to decode the packet successfully, it sends an ARQ for the sender. The sender again sends another data packet. But if the ARQ of the second data packet didn't reach the transmitter within the time period specified by the timer at the transmitter, it just gets expired, and the transmitter decides that I'm no longer gonna receive any ARQ for the previous packet. I'm gonna drop them. I'm not gonna get confused, and I will consider that the data packet was not received successfully, and therefore I'm gonna resend the data packet again. Of course, there are two things here. There is maximum number of retransmission you can send and maximum time you are allowed to take. If you cross any of these, the receiver will report to the transmitter that the packet is dropped, and there is no way of retransmitting again. These are the two conditions: maximum number of retransmission and the maximum time allowed for you to send your ARQ message to the receiver, to the transmitter. Now, although this protocol a little bit helped improve the performance furthermore compared to stop and wait, but still it has some problems and drawbacks. The first problem is this protocol sends one frame at a time, and therefore this results in poor utilization of the bandwidth and accordingly poor performance. Your throughput is very little because you just send one frame at a time. You are not utilizing the bandwidth efficiently because there are time instances where you are not sending anything. The channel is idle, is not utilized, is not used, and this decreases your throughput and your performance will not be that good. To solve this problem of associated with the stop ARQ, stop and wait ARQ protocol, and improve the throughput of it more, we use the idea of sliding window protocol. So what's the idea of sliding window protocol? So instead of sending just one frame at a time, you are sending multiple frames at a time. The number of frames to be sent is based on the window size. Who determines the window size? The transmitter, by agreeing with the receiver. And each frame is numbered, and this number is called the sequence number. What are the protocols that adopt and use sliding window concept? We have two protocols: the go back in ARQ and the selective repeat ARQ.